Hi friends, let's fine-tune GPT 3.5 on our custom dataset and custom format using OpenAI. Now, the process to fine-tune the state-of-the-art GPT-4 is also exactly the same, but OpenAI hasn't made it available yet. Okay, we discuss the advantages and disadvantages of fine-tuning as opposed to prompting at the time of inference towards the end of the video. But let's jump right into the code. Okay, so today we are going to work with a very interesting data set. It's called Science QA, question and answering a data set. So think of it like we have a teacher delivered a lecture and then ask questions and provide multiple options to choose from, right? So the question also have a context, right? Then the student supposed to choose the right option from the provided multiple options and also provide an explanation of why he or she choose that answer. Okay, so that's the data set. Now today we are going to use the lecture, the question and the multiple options. So we provide these three pieces of information to an LLM and we ask it to choose the right answer from the multiple options. Okay. All right. So this data set is available from Hugging Face datasets and load the data set. It's divided into this train, validation and test. Here you can see the number of records in each dataset. Now, in addition to these columns we discussed, it has multiple other columns. For example, what skill, what category, the topic, etc. But as I mentioned, we are going to work with only the lecture, question and options. Okay, only the three variables. Now, I just converted the dataset into a pandas data frame here. And this is for demo purpose. We are only working with the first 10 examples. Okay. So here, for example, let's look at one of the records. So here we have a lecture talking about the maps and directions. And then we have a question, which of these states is farthest north? And then we have four multiple options provided: West Virginia, this Louisiana, Arizona, and Oklahoma, right? And the correct answer is 0 means it's the first option. Okay. All right. Now coming to OpenAI fine tuning, the most important task is preparing the data in the right format. Once we have done that, fine tuning the model is super easy because OpenAI made it into very high level APIs. So fine tuning the model is super easy. Preparing the data set is where we need to be really careful. So OpenAI expect a JSON line file, meaning we need to have one line per example. And here we have one example, right? So it mainly has three parts to it. One is the system, the second one is the user, and the third one is the assistant. And each part will have two components, right? Role and the content. For example, so here we have role, the system and the content. So the system content will tell the LLM how it's supposed to behave, how it's supposed to answer, or what this data set is about, etc. Right? So it is like giving a persona to an LLM. Okay. And then we have the user. User is us asking a question. So the user content is now how do we ask the questions, what sort of information we provide, etc. Right? So the assistant is LLM returning us the answer. So the assistant content actually contains the answer. Now, why we have this very specific format? Because the OpenAI GPT models, those are conversational LLMs, right? So for that reason, we need to prepare the data in this conversational format rather than a simple question and answer. Okay. So let's prepare our data set in this format. All right. Now, a bit of formatting the data. Now, as we saw here, the choices, those are a list in the form of a list, right? Now what we want to do is we want to format the output options like this. So we want to convert this list into these multiple options A, B, C, and D, so that the model can return which one is the right answer, right? So we are simply creating these alphabets from A to Z, and then we have a very simple function which take the options list and convert them into in this format. Okay, so we are simply zipping the choice prefix, which can be A, B, C, or D, and then the actual choice. Okay, and then we use the pandas apply so that we applied it on each row. So axis is equal to 1 means we are applying row by row. All right, so our new choice formatted column, it looks like this. Okay, all right, and then because we have these answers from 0 to 3, let's convert that also into this ABCD format, right? Because the options we are providing are like ABCD. So let's turn the right answer into ABCD. So we just created this simple map, and then we use this replace, pandas replace, so that as you can see from here, our answer, it's now either A, B, C, or D. Okay, so the choices formatted, as you can see here, we remove that list and we made it into these 4 multiple options. Okay, all right, and then the interesting thing about our data set is it's not like for example here the user content, it's not a simple question, right? So the user content has a context in the form of this lecture, has a question, and also has these multiple options provided. So we need to combine these 3 pieces of information to make the user content. Okay, so that's what we are going to do next. So we wrote a simple function, these combined columns. So what we are doing is we are returning the lecture, the question, and the multiple choices, and we are adding this suffix so that the model can understand what the context, question, and multiple options are. Okay, so again we call the pandas apply function on the data frame row by row. For example, the first record, it looks like this. So the user content, it has this context, which is the lecture by the teacher, and then here we have this question, the question part, and then we have the options A, B, C, and D. Okay, yeah, so this is the most important part, right? To be able to inform the LLM what our how our custom data set look like and the format it expects. Okay, and then so we have created this user content, and then the assistant content is simply one of the 4 options, right? So these 2 are ready. Now we need to create the system prompt. Now, as I mentioned, the system prompt inform the LLM how it's supposed to behave, what to expect. It sort of give the LLM a persona. Okay, so here I have some persona for the LLM, which says you are serving as a science teacher assistant. Okay, your task is to respond quickly to multiple choice science questions provided by the teacher. Each question will be accompanied by up to 4 answer choices labeled as A, B, C, or D. Your goal is to select the most appropriate option from the provided choices. Okay, so this is the most important one. As I mentioned, our new model is going to behave based on what our system prompt is. Okay, so this is we have to be very careful with system prompts. All right, and then again another very small helper function, given a pandas row, it will prepare the data in the format the OpenAI expects, right? Like this, the messages, the role, and content for three different roles we have: the system, user, and the assistant. Okay, so here we have a simple helper function, and then we are opening this empty file, JSON file, and going over the pandas data frame row by row. And then our question is the user content, which is a result of combining the three columns, right? Combining the three columns, which are the lecture, the question, and the options. And then we have the answer, which would be the content for the assistant. Okay, so we open the file and we write the data to a file, right? So now if you look at the data, for example, here we are looking at the very first record from train.jsonl. So this is how it looks like. So the messages, so the first one, it's a system role, and here we have the system content, which is the default system prompt. Okay, hey, you are an assistant to a teacher, so on and so forth. Yeah, so up to this point we have the system content, and then we have the user role, which is us asking the question. But unlike a generic case where we simply ask a question, here the user content has three pieces of information, right? First, the lecture in the form of this context. For example, here it talks about the maps, the directions, etc. And then we have the question, which of these states is farthest of north. And finally, we have these four options, right? So all these three pieces of information is part of the user content. And finally, we have the assistant role, and the content is simply which of the four multiple options is the right answer. Okay, so this is the most important part, right? Preparing the data in the right format. Once we have prepared this data, fine-tuning the model is super easy, right? OpenAI has made it super easy for us by creating high-level APIs. Just looking at the last record, I'll share the notebook. You can have a look. And then before we jump into training the model, the OpenAI, they have provided a bunch of helper functions to make sure we have prepared the data in the right format and some certain conditions are met. Okay. So this one, we are just reading the file and just printing how many records we have, right? So we have total 10 records, and this is our first record. But from here, we have the code provided by the OpenAI. So in the first one, all it is doing is just going over the records one by one and then checking if they are in the proper format. So as I mentioned, the proper format is here, right? So it's supposed to have these three pieces of information: the system, user, assistant, the role, and their content. So this piece of code, it's simply going over the data and making sure that the roles, the three roles and the three contents are in the proper format. Okay, so it says no errors found. All right, so as I mentioned, this code is provided by OpenAI. And then we want to know how much how many tokens are there, how much it's going to cost us, right? So again, some helper functions to understand that. Okay, all right. So here we have the helper functions, and then here we are calling them. Now the most important part is to make sure these two we don't have any missing information or errors. So it says the number of examples missing the system message is 0. The number of examples missing the user message is 0. Okay, so we are just checking if there are any examples in our data set with the missing information for the system role and the user role. Okay, some distribution, we don't need to worry too much. And then finally, we want to understand the cost, right? So this piece of code is also by OpenAI, but again, it's not necessary we run this code, but it's to understand that we prepare the data in the right format. We know how many tokens we have. We know how much it's going to cost us. Okay, so it says we have total of 3,481 tokens. That's too small because we have only 10 examples, right? And then it says if we are going to train the model for 10 epochs, we are going to be charged for these 34,000 plus tokens. Okay, so the way OpenAI charges us for fine tuning the models is, it's simply the total number of tokens we have in the training data multiplied by how many epochs we are going to train. Okay, so we have total 34,000 tokens, assuming we will be training it for 10 epochs. And then here is the pricing page. For GPT 3.5 model, it cost some $0.008 per 1000 tokens. Okay, so to train a new model on our own data set, which is too small, just 10 examples for 10 epochs, is going to cost us some around 25 cents. Okay, all right. Now comes the OpenAI part. Okay, to quickly summarize, all we have done is we know what data format OpenAI expects. We did some pandas data formatting, some simple mapping, etc. And we prepared this train.jsonl file, right? And the steps after that are just to make sure we prepare the data in the right format. We know how much it's going to cost. Okay, right? These three cells. Now comes the training part. So as I mentioned, it's super easy. So simply export OpenAI client, and then first we need to upload our training data file, right? So using the files create, provide the file path, and the purpose is fine tune. Okay, and get the response. From the response, we can get the file ID. Okay, so this is our file ID. So response.id, this is our file ID. We need the file ID when we fine tune the model, because we supply the file ID, not the file name. Okay. All right. Some other information, not so important. I mean, when the file is created, the size of the file, etc. Okay. And then it is as simple as simply creating a fine tuning job. Okay. So at the very basic, we need two pieces of information. One, what's the file ID? And the second one, the model. Okay, so GPT 3.5 Turbo. If we were to fine tune GPT-4, we would simply have GPT-4. But as I mentioned, it's not available to everyone yet. Now we can provide these additional optional parameters. I guess by default, the epochs is 10. But if you want to set some hyperparameters, we can set in the form of this dictionary. So here I set the number of epochs to just 2. And we can also provide the validation file. So the format is exactly the same. We can prepare another file and provide that as a validation file. Okay. And simply submit. And now this error is because I was running a few other lines of code within the same cell. So the error is coming from the other code, not from this one. Okay, so you can ignore this. I don't want to rerun the fine tuning, so I left that as it is. I removed those lines which have causing the error, right? So from the response, we can get the fine-tuned job ID. That's important, right? To get how the model training is performed, to get the new model name. Okay, so here we can list the events by providing the fine-tuned job ID. Okay, so as you know, this fine tuning is going to take some time. Now this list of events, it contains the information about the status of the fine tuning, right? If it is in progress, what step it is, the training accuracy, so on and so forth, right? So what is happening during the model training. Now, if we want to automatically check the status, we can write another function where we call this function, let's say every 10 seconds or 30 seconds, depending on how long we expect the model to take. And then we can print the information synchronously. Okay, but this model hardly took 1 minute to train. Now, once the training is done, here we can retrieve the training job information using the job ID. Okay, the most important one here is, so here we have, this is the one we provided. The most important one here is this fine-tuned model. Okay, so the fine-tuned model. So OpenAI, the new model created, it's fine-tuned GPT 3.5 Turbo. That's the base model. So 0613 is also part of the base model. Now here we have this personal, and it has appended some random ID, right? So this is going to be our new model. So when we do the inference, this is what we are going to use. And the other important information is this results file. Okay, so as you can see here, it created this file. Now let's get the file name. Okay, so we have the file name here, and then we can call this function retrieve content with the file ID. Okay, with the file ID. So the response is this, it's a string. So let's split by new line. So here we have the step, the train loss, train accuracy, validation loss, and then validation mean token accuracy, right? Since we have not provided a validation file, so the last two columns are empty, but you can see here the step, the train loss, and the train accuracy. So at the beginning, we have the train loss somewhere around 4.5 or close to 5-ish. And towards the end, this is around let's say roughly around 2. Okay. All right. So from the response, I mean, as we saw here, we can get the fine-tuned model name also. All right. So we get the model name. This is our fine-tuned model. All right. So the model is fine-tuned and hosted by OpenAI. Now, in order to use the model, so we have the user content, right? So here is the lecture. Here is the lecture. And then we have the question. And then we have these two options. Okay. So to call the function, we simply do like we are invoking ChatGPT 3 or ChatGPT 4, except that we provide the model name, our own, we give it our own model name, right? So it's chart completion create, provide the model name, and then supply the system prompt and the system content, which is the same as we used for training. And then we have the user content. Okay. So the model response is the content B and the physical change. So we are asking if this process is a physical change or chemical change. The answer is the physical change. Now I expected it to return only B without providing this, because that's how we prepared the dataset. But maybe because we fine-tuned it only for 2 steps and we have only 10 examples, it hasn't followed strictly. Or maybe we need to define the system prompt more carefully to say return only either A, B, C, or D without the actual answer, right? So here we said your goal is to select the most appropriate option from the provided choices. We did not make it explicit to say just return A, B, C, or D only without the answer. So maybe if we add that one, we will get only the a label as opposed to the label plus answer. All right. Now here I have one more example, but I want to show you this. So here we are calling the model without any system prompt. Okay. As you can see, the system content is empty, but the model is still able to answer or do its job as how it's supposed to be doing. The reason is because it is a fine-tuned model, it already has persona, it already know what to expect, how to behave, etc. We don't really need to provide this system prompt unless we want the model to behave differently to what it's tuned for. Okay. So that's one of the major advantages of fine-tuning. Okay. Because here we don't need to supply the system prompt every time, right? So if I go back here, so the advantages, we have higher quality results as opposed to the prompting. And because of the context limit, when we do the prompting way without fine-tuning, we can only provide few examples as a few short learning, right? Whereas if we are fine-tuning, we can fine-tune the model with as many as we wanted, as many examples, right? And with the fine-tuned model, we will have shorter prompts because we don't really need to supply the system prompt, and that results in this low latency, right? Because the model, it already know how to behave, how to answer. So it provide the answer quickly, as opposed to prompting where in each prompt we have to explicitly state how the model is supposed to behave. But the disadvantages, obviously it's expensive, it might require some special hardware. Now this one, again, just 10 examples, 2 epochs, but imagine a real world scenario where you want to train on your enterprise data, or maybe you want to do it for natural language to SQL again on your enterprise data. We might need to have thousands of examples and need to train over hundreds of epochs, right? So there the cost really blows up. And again, at an enterprise level, if we were to train one model for each use case, then this LLM ops becomes cumbersome, because we have to develop pipelines, the manage, the versioning, and all those things, right? Whereas if we use a general purpose model, just during the inference time, we use the system prompt differently for different applications, right? So fine tuning has both advantages and disadvantages. And yeah, so if you no longer need the model, you can delete it simply by invoking this models delete command. Again, supply your fine-tuned model ID. Okay. All right, that's about it. As I mentioned, training the model is super easy. We just have to be very careful with how we prepare our data. That's all for this video. Thank you very much.